Walking sucks. We're in the golden age of technology. I should not have to use these things to get me around town. I'm gonna make something better. That's right, I'm gonna make an electric longboard. So I've actually been planning this for I think a few years now, but I'm just now getting some of the components to make it actually work. Oh, this is gonna be awesome if it works. Let's get started. What's up, humans? Davis here, also known as Fluffball, and if you didn't know, you are watching Fluffball the Wizard. I'm sure most of you know what an electric longboard is. Pretty self-explanatory. It's a longboard that's electric. To be a bit more descriptive for anyone that might not be familiar with this, a longboard is similar to a skateboard, but distinguished primarily by its length, hence the name. Secondly, its wheels, which are a lot bigger, boxier, and softer than skateboard wheels. And lastly, the trucks and deck are designed slightly different, and all these things combine to make the longboard a lot better suited for transportation as opposed to tricks at a skate park. Now, even though a longboard is designed for convenient transportation, not everyone's route is very easy to pedal on. Sometimes the route could be almost all uphill, maybe a bit rough terrain, a lot of people to navigate through. Any of these things makes pedaling difficult because every time you push off with your foot on the ground, you lose like 80% control of the board. And it's just for that second, but if you have to do that every 5 seconds, not only is that tiring, but it also means you gotta be really careful because things can go very south very fast. Enter technology. An electric longboard makes use of rechargeable batteries, usually lithium polymer, and electric motors, usually brushless direct current or BLDC, and it uses these to overcome those problems. Now, there are 3 main techniques to get one of these motors to spin your wheel. Probably the most common, especially with DIY boards, is belt driven. This means your motor is positioned offset from the wheel and there's a belt going from a pulley on the motor to a pulley on the wheel, and that's how the motion gets transferred, similar to a bike chain. The problems with these are, 1, there's more moving parts than necessary, which means more maintenance and more points of failure, and 2, they are as loud as a freaking fighter jet. The second most common is what's called hub motors, which means there's a wheel that's specially designed to fit a motor inside it, and the motion just happens that way. These are super cool. They're quiet, not a lot of moving parts. But it also means you're stuck with whatever wheel it comes with because you can't put a motor inside a normal wheel, and the hub motor wheels often have compromises that reduce comfort and or efficiency. And you're also stuck with the motor it comes with, which is limited in size because it has to fit in that wheel. Also, since the motor is surrounded by the polyurethane wheel, that means that these tend to heat up a lot more, so I was kinda skeptical about all of that. Least commonly, but certainly not least practically, we have direct drive. This method by far makes the most sense to me. We have a motor in line with the axle that your wheel is on, and it has some extrusions that just fit into the holes of your wheel, so then it just rotates it that way. This means it's quiet, not a lot of moving parts, you can do whatever wheel you want, whatever motor you want, and everything is open for cooling. Awesome. So why is direct drive the least common if it makes the most sense? It's freaking expensive. We're doing it anyway! Right, so a couple of things. First of all, most of the reason these are so expensive is because not only is it direct drive, but it's also dual motors as opposed to a single motor setup, and that'll give me a lot more torque for hills and acceleration. I actually ordered these motors in late March of 2019, and they were scheduled to arrive in early May. Now, admittedly, I was catching the tail end of pre-ordering, so it was expected that they wouldn't be right on time. However, they did assure me that I was in the right tier and that they were on schedule. June comes around, still nothing. I reach out like, hey, what's up? And they're like, oh yeah, we had some units that didn't pass quality check, so expect yours late this month. I'm like, alright, at least they do some decent QC, I'll wait. July comes around, finally receive my motors, and they're the 90 kV rating instead of the 75s, which I told them I wanted instead. I send those back, and when they arrive, turns out they're out of stock of the ones that I ordered. Bunch more email back and forth, and finally, in freaking October, this package arrived at my door. Okay, after 6 bloody months, half a year, I finally have the package I've been waiting for. Let's see if it's actually the right product this time. Oh my gosh, it's so heavy. 75 kV, that is more like it. finally have some motors. Alright, so I've got these 85mm 80 Duro longboard wheels from Orangatang. To go with them, I've got these sealed bearings from Atlas. Let's get those in there. There we go. A couple of wheels all bearinged up. So now we're gonna grab these trucks. We're gonna see how these wheels fit on here first. Now we want this tight enough that there's no give to it, but not so tight that the wheel has trouble spinning. Perfection. So there are these trucks all completed. They are nice and smooth. Now let's do the motorized ones. Ready? Boom. Oh yeah. So this is awesome. We've got the motors rolling here, and this thing is heavy, let me tell you. Now one thing I'm gonna need to consider, I actually started with 80mm wheels here, but I quickly noticed when designing the CAD model for this that was gonna be too small because that was almost exactly the same as the motor. And even with the 85s, like that is how much ground clearance I have to work with here. That's not a lot. All else fails, I can just get even bigger wheels. I'm hoping that I don't have to because good longboard wheels are not cheap. Nothing about this project is cheap. I'm spending so much more than I thought I was going to. But hopefully it'll be worth it, because this looks very promising.
1 hour later.
So I was just like messing around with these and like admiring them for a bit, and it's setting in more and more how huge these are. Like, these are comically large. This is ridiculous. I thought I was building a longboard. This is going to be a wide board. Like, here's my perspective. Look at this. This is insane. Like, here's my school backpack for reference. It's ridiculous, but it's gonna be so sick. I am excited. Okay, a couple more things worth mentioning. No matter what motor style you use, whether it be belt drive, hub motors, or direct drive, your motors have a couple options for any of those setups. One thing I already mentioned is going with dual motors instead of singular, or if you really want to go all out, maybe for off-road or mountain boarding. I've even seen some setups with quad motors, basically all-wheel drive. Another option your motors have is censored or uncensored, not to be confused with censored or uncensored, which refers to media and such. Censored motors are equipped with a magnetic field sensor to detect the position of the motor, called a Hall effect sensor. This helps tremendously with having smooth starts and stops, as well as making the ride itself smoother and more efficient. Both of these things affect what ESC you should get. All brushless motors are going to have the 3 big wires here. These drive the magnetic coils in there, which makes the motor turn, and it's also why you need an ESC to drive brushless motors instead of just applying a straight current to it, because of the way these are designed. So your speed controller works out how much current and when to send to these. And if your motors are censored, they will also each have a cable consisting of 5 or 6 wires coming out of it as well. Now, I've heard that the VESC system is best among the community of e-skateboards and longboards, so I picked up a dual censored board for these motors, and the one I found also includes a built-in anti-spark switch, which is awesome because these can run anywhere from 50 to 70 bucks on their own. I also quickly noticed that none of the ports here match the sensor cable that I have, but this board also includes the right adapter cables for that, which is awesome. It also has a nifty place to plug in your radio receiver, a micro USB cable for programming, and even a 1-page double-sided manual for getting you started, which is amazingly helpful because I have no idea what I'm doing. The only thing I had to buy separately was a pack of bullet connectors to match the ones on my motor, which through some Googling and measuring I found the right kind and how to solder them onto my ESC. Before you start, make sure your iron can go up to at least 800 degrees Fahrenheit. Anywhere from 800 to 850 is optimal for bullet connectors. The main thing is you need your iron hot enough and fully inside the connector long enough that it heats up the entire area where the solder goes. Once everything's hot enough, then we can start feeding in some solder, which should just instantly melt into a nice little puddle. It's a really clever system and makes for a very secure connection to the wire. Put some heat shrink on it, and there we go. Now, this is a Flipsky board, and it does say it's compatible with the official VESC software, but in order to use that, we're going to need to access one of the micro USB ports here. We'll also need to get to some other ports on the board for sensor wires, but I want to keep this heat shrink casing on here for now to get that extra protection. So, I'm just going to cut out the sections I need with an X-Acto knife. Alright, so we now have access to a micro USB port, both ports for the sensor wires here, and the anti-spark switch. And the port for the switch, which can now be removed. I said, can now be removed. Can now be removed. Frick. With just a little bit of force. So now when we're building this thing, we can take off the nut like we're supposed to. Then we're going to have our board with a hole in it for the switch. We can thread this wire through the front of the hole and then have the switch fit nicely. Then we thread the nut back over the wire. And that'll go back over to the back side of the board and secure the button in place. And then from there, we have our button in place and our wire can be plugged back into the board. So there we go. This board is almost ready for testing. We've just got our battery wires here that don't have anything on them yet, because I still need to pick out a battery for this. And that'll be in the next video.
Alright, now you might be able to tell I'm getting pretty sick, so apologies if I look or sound like a mess, it's because I am. Anyway, getting a motor in ESC might not have looked like much, but after all the months and months of research and planning I did beforehand and didn't show you, this is a huge step for me. Just to clarify, I've never done anything in this realm before. I've never touched a brushless motor or ESC, I've never even built a regular longboard. Heck, that was the first bullet connector I've ever soldered. So in the next video, among other things, I'll be getting a battery so that all of this can actually do something. And I haven't ever worked with big LiPo batteries either, so that'll be fun. Don't blow yourself up, you moron! I can say about the products in this video that even though I haven't used them yet, they seem to be pretty high quality. The bullet connectors do fit nice and snugly with the motors. I have actually been using slightly smaller Orangatang wheels with the same Atlas bearings for my skateboard, and they've been doing absolutely fantastic. So I will be providing links for all of the stuff purchased in this video for the project in the description if you want to follow along and try to build this yourself. Just know that I still have no idea what I'm doing, so until I finish it, you're buying the electronics at your own risk. Until then, I think that about wraps things up. If you like this video, there's a handy button for that. If your jam is a lot of my content here, then don't hesitate to subscribe to Fluffball the Wizard. And until next time, make more, sing more, hug more. Catch you guys next time. Until then,